Hello, and thank you for clicking on this video. I will present to you our work, RadEdit, stress testing biomedical vision models via diffusion image editing. Compared to natural image datasets, we find often that medical datasets are quite small. And in addition, the data might come from a single hospital or single source and is therefore biased. You can think of like a specialized hospital that treats patients with a certain disease. This will lead to this disease and a certain patient demographic being overrepresented in the dataset. If we now train a classification or segmentation model on this type of data, our model might fail to generalize to data from a different hospital or different source. And the big question now is, how do we find out that our model doesn't generalize? And this is what we want to address in this paper. In the best case, of course, you would have plenty of real data with a diverse set of disease from a diverse set of patients, but it's pretty much never the case. So we want to create synthetic data that helps us to stress test existing biomedical vision models. It does not matter if we trained those models ourselves or if we downloaded the latest and greatest foundation model. And to be more precise, we want to use image editing to create images with a combination of image features. And these image features can come from diseases, support devices like pacemakers, or the equipment of the hospital itself. The advantage of image editing is that it lets us create images with a combination of features we can choose that are potentially rare in the real world. We first tried simple prompt-based editing, but realized quickly that the edited images could not be used for stress testing. The main problem is that diffusion models trained on medical data are biased themselves. To fix this, we came up with an editing method that restricts the area of an image that can be edited by the diffusion model while still ensuring the consistency of the entire image. I will now explain the steps of RadEdit using an example. In this example, we want to stress test a segmentation model for lungs trained on X-ray images from healthy patients. If we test the model using an X-ray image of healthy patients, we see that this works great. The lung is fully segmented and the segmentation matches the ground truth. We now want to edit this image so we can see if the segmentation model also works with patients that, for example, have a pacemaker. It is important that the shape of both lungs is still the same after editing, since we need to use the same ground truth segmentation labels for testing. RadEdit takes 4 inputs: the original image, a prompt for editing, here just the word pacemaker, a mask indicating an area where the edit should happen, and a mask indicating an area that should be unchanged. I mentioned earlier that RadEdit ensures consistencies. In this example, this means that we allow RadEdit to change the area outside of the left lung as well to complete the pacemaker that is only partially overlapping with the mask of the left lung. Please keep in mind in X-rays, left and right is swapped. And if we now stress test the segmentation model using the edited image, we find that the segmentation model fails to ignore the pacemaker, which is not part of the lung. So we show the model does not generalize. If you want to see more use cases of RadEdit, more quantitative results and ablations, please check out our paper and our GitHub repository. Thank you.